In this video, we're going to go over chi-squared, but a different type of chi-squared test than we had done before. And let's just go right down to this example. And we're on the two-way table data for section 13-2 or 13.2. And so this happens to be question 14 out of your book. And we want to find out, how are the smoking habits of students related to their parents' smoking habit? And here are some data that are from a survey of students in 8 Arizona high schools. And they found a total of 5,375 students. And of those, some of the students smoked. In fact, it ended up 1,004 smoked and 4,371 did not. But they categorized those on how their parents had a smoking habit. And we found that 400 of the students had both parents who smoke, and then if we look at of the parents who both smoke, we have 1,380 of the students don't. So a total of 1,780 students had both parents smoking, but it looks like most of them, if you're going to compare the two, don't smoke. For one parent smoking, we had 2,239 students who had at least one parent or had one parent who smoked. And we can see that of those 2,239, we have 416 who smoke and 1,823 who didn't. And then the last one, if we look at neither parent smoked, we had 1,356 people who neither parent smoked, and of these 1,356 students in that category, 188 of them smoked and 1,168 did not smoke. So I found the row totals and the column totals, and we'll find that that's very important to do when we do this type of a test. We have 3 rows and we have 2 columns. Now, I wanted to calculate the proportion of students who smoke in each of the 3 parent groups. So if you're in the parent group where both of your parents smoke, we know that 400 out of 1,780 people, or about close to 23%, smoke in that category. Now, if I look at the proportion if one parent smokes, I labeled that P hat 1, we know that 416 students smoke out of the 2,239. So that's only 18, almost 19%. And then if we have neither parent smoking, our proportion is 188 out of 1,356 smoke. Now, if I look at these 3 proportions, our chi-squared test is basically going to tell us whether these proportions are different. We could do 2 proportion z-tests. We could compare these two and find out if there's a significant difference between having a student smoke if they have 2 parents or 1 parent. We could find out if there's a significant difference in a 2 proportion z-test between 1 parent smoking and neither parent smoking. And then we could do a 2 proportion z-test to determine whether there is a significant difference between people who have no parent smoking and have both parents smoking to see whether that smoking habit is affected. So I made a little graphic display. I put the proportion of students who smoke along this axis. And I can see that it does appear, particularly these two, definitely seem to be different. Now, are these 2 proportions different? Are these 2 proportions different? We'll see. But it definitely looks like these 2 are going to be different enough. So our chi-squared test is going to help us answer that question. So how do we perform the chi-squared test? The test statistic when we do this type of analysis in a two-way table where I have two variables. I have a parent smoking habit on an axis and I have a student smoking habit on an axis. The chi-squared statistic is still calculated exactly the same way. So let's look. So start out, explain in words what the null hypothesis says about a student's smoking habit. We're going to assume that the actual proportion of students who smoke who have no parent smoking, 1 parent smoking, 2 parent smoking are all the same. So we're assuming that the smoking habit of a parent does not influence the smoking habit of a student, that these proportions are going to be the same. So the parent smoking doesn't cause these to be different. Now, we know when we calculate chi-squared, the chi-squared statistic has to take observed, which we know how many are in each of the categories. So that's not hard. But we need an expected. How many would we expect? If these proportions are actually true, how many would we expect to be in each of these little categories? So we know we need to be able to calculate this, and then we'll calculate the test statistic the same way by adding up some components. So how do we calculate the expected value for each of these different categories? So we look at this little table in here, and we can see that there really have to be 6 different expected values. We have a certain number we would expect here, and a certain number we would expect here, and so on, and that would be based on these proportions being the same. So what we do to find those expected values is we take the row total times the column total and divide it by the table total. So the expected counts are take the row total times column total divided by the table total. And so you can see what I did to find this number is I took 1,780 times row total 1,004 and divided it by the table total, and that gave me this value. Likewise, I can take row total 1,780 times column total 4,371 and divide it by the table total, and that gives me this value. And I did that for all these different cells. So these are the expected values, and if we actually take this number divided by 1780, this number divided by 2239, and this number divided by 1,356, all 3 of those proportions will be the same because our assumption is that each of these categories, as far as the parent smoking habit, has no influence on the student smoking. So the proportion here and here and here would be equal. So that's what these expected counts do. So now we're ready to find our chi-squared. So let me go back. I'm indicating here that if we wanted to find the expected count, if it's true, and display them in the table, we did that. Here's just one of the cells. This was the row 1, column 1. And we want to do a chi-squared analysis. So we are assuming that we have simple random samples. All of the expected counts in that table were all in the hundreds, so they were all plenty big, at least 5, so we're ready to perform our test. Never forget to write your hypotheses down. So we're going to assume that the proportion of students who smoke in each of these categories is the same. Alternately, they're not all the same. Now we're going to calculate the chi-squared. Now notice how I have the components. I have outcome, the observed, minus the expected squared divided by the expected, and there actually are 6 little categories, plus, and then we go all the way to here. So let me flip back over and we can see where these come from. I would take observed minus the expected squared divided by this number, plus observed minus the expected squared divided by the expected squared, observed minus the expected quantity squared divided by the expected, and so on. And I would add all those up. So we can do that very nicely in another little table where we could do just like when we did the previous section. Now, the question is how many degrees of freedom? Because we know how to calculate the chi-squared. Same way. Well, the degrees of freedom is not probably what you think it is. You'd probably look at this and say there are 6 categories, so hey, probably 5 degrees of freedom, just like the previous page. And that's not the case. The number of degrees of freedom is actually however many row totals you have, less 1, times the column total. So we have 3 rows here, and we have 2 columns. So if I multiply 3 minus 1 times 2 minus 1, I find out I only have 2 degrees of freedom, not the 5 that I may have anticipated having. So I have 2 degrees of freedom. So we know that that chi-squared category always looks like something like that, a skewed to the right distribution, and we have 2 degrees of freedom. And so we're trying to find where does this 37.566 that I got for the chi-squared total is. That area right there is my p-value. And again, it's very small. I could use my my chi-squared CDF to find that. So I definitely have evidence against the null. I know that the proportion of smokers in each of these parent smoking categories are not the same. However, who is different from whom? And we can actually use our calculator to help us do that. So let's go to Stat and Tests again. And let's try to find out whether there's a difference between, now let's flip this over so we can see. Why don't we compare 1 and 2? Let's find out if, assuming that the proportion of students who have one parent who smokes and the proportion of students who have two parents who smokes, we're going to assume they're equal. And alternately, they're not equal. So we're going to do a 2 proportion z-test. Now, in my first category, I have the actual number of people who smoke. I have 416 out of 2,239. And if both parents smoke, I have 400 people who are in that category out of a total of 1,780. And I'm just trying to find out if there's a difference between those two proportions. And I calculate. Now, this is giving me, if we actually went through and did the test and so on, that the test statistic is really going to come out to be this negative 3.5, I guess I should say. And we're doing a not equal to, so we're really doing a two-tailed test. So we'd be finding these two areas to find our p-value, and that p-value is 0.0023. Well, we definitely have evidence against the null. We have evidence to say that the proportion of students who smoke if they have one parent versus two is definitely not the same. We have strong evidence against that. This p-hat 1 is actually what proportion we have for this value. The p-hat 2 was this value. And this was really the pooled p if we went through and did the longhand calculation out for our analysis. And remember that pooled p is when we take and combine the two samples together to find out what these two are actually being set equal to. And so that pooled p would have been that 400 plus the 416 out of the 1780 plus 2239. So that's what this value is. And let's see what else we have down here. Oh, and it tells us our two sample sizes below. Okay, and likewise, we could go through and find out if there's a difference between 0 and 1 and between 0 and 2. And I believe I've done all of these, and I think all of the categories. I don't think any of the proportions are actually equal. Okay, so that will get you started, and we'll go through the other example in the next video.